My name is Mr. Cleophas. Welcome to my YouTube channel. Today, I want to do a concept called an application of what? Marginal costing. Remember, there is a topic called marginal and absorption costing. But today, your teacher here wants to do and the one of the applications which is non-routine. Under the applications of marginal costing, they are categorized into two main categories. That is the cost volume profit analysis. That is the first application. Number two is the non-routine decisions. Non-routine decisions. We have different non-routine decisions. Make or buy is one. By the way, let me start with number one. Number one, the limiting factor. Limiting factor decisions. Limiting factor decision. There is also the make, the one I'd written, make or buy. Make or buy decision. There is also where you have special offer decisions, special offer decisions, special offer decisions. So I want to start with this limiting factor. And I may not be able to do the three in one class or one video. So let me do a limiting factor question. Let me have my plastic paper here. I look for question. This is management accounting, intermediate level. For those who are doing CPA, I want to look for one question here. Great. This is watch sitting, December 2023. So here we are. So December 2023. This is question number what? 1C. This is CPA past paper, management accounting, December 2023, question number 1C. Let me read that question. You can get these questions online, no problem. Then you follow the question step by step. You are going to understand the question. When you talk of the limiting factor decision, sometimes organizations are faced with some scarce resources like hours or the labor hours. It can be a scarce resource. You want to produce more, but the hours available are not enough. So you need to make a decision on which is the most optimal product to produce based on the available labor hours, because maybe the demand is high and it requires more hours or direct labor hours. Then you need to be very keen on which product to produce more so that you make maximum profit or you optimize the profits. So you need to come up with the optimal production mix. You need again first to determine what is the shortfall or the deficit in that scarce resources, in that resource which is not enough to meet the demand requirement. So you compute, this is the available hours, then you get what is the required labor hours. The required hours minus the available hours, you get the deficit or the shortfall in that scarce resource, which could be the labor hours for this case. After that, you need to follow the steps of optimal production mix or under limiting factor, where is the first thing is to identify that limiting factor. After you identify the limiting factor, you need number two, you need to compute what we call contribution margin. After you get the contribution for each of the products, then get the contribution per limiting factor, meaning contribution for each of the products, then divided by the limiting factor. After that, you need to rank those products based on the contribution per limiting factor. The product with the highest contribution per limiting factor shall be ranked number 1. The other one following it, number 2. The other one, number 3, number 4, like that. Then you produce as per the ranking so that you now get your optimal production mix with the available labor hours or with the available scarce or limiting factor or the scarce resource. So that is the essence of limiting factor concept. It is a non-routine decision. You don't make it on a daily basis. It is not a routine decision. It is a non-routine decision, meaning it is not a decision which is made on a daily basis. It is done or it is made occasionally, meaning it is not a repetitive decision. So let's read this question, December 2023, question number 1C together. So let me read it for you. It says this. Jiffy Limited has been manufacturing and selling 3 textile products. The following details are available for each of the 3 products. We have the products there: cotton, linen, and polyester. We have the direct material, and shillings are given for each of these products, shillings per unit. Direct material for cotton is 350 per unit, linen is 365, and polyester is 255. Direct labor, it is 480 to 40 and to 10 for cotton, linen, and polyester respectively. Variable production overhead is 150, 115, and 205 for cotton, linen, and polyester respectively. Fixed production overhead is 300 for each of them, that is cotton, linen, and polyester. Each has got a fixed production overhead cost of 300 shillings per unit. Total cost per unit for each of the cotton, linen, and polyester is 1280, 10, 20, and 970. Selling price per unit for each of these products is 1600, 1340, and 1300 for cotton, linen, and polyester respectively. Net profit for each of the cotton, linen, and polyester per unit is 320, 320, and 330. Budgeted annual demand in units. So this is the annual demand in units for each of these products, cotton, linen, and polyester, is 1600, 2400, and 3000. Additional information. Each direct labor hour is charged at 110 shillings for cotton, 120 shillings for linen, and 70 shillings for polyester. The direct labor force is threatening to go on strike for 2 weeks. This means that only 10 100 hours will be available for production rather than the expected 20 to 100 hours. Okay, so I don't need to get the required labor hours, so you have a shortfall or a deficit. So the first thing you can check on the shortfall, which is the required direct labor hours minus the available direct labor hours. Though the question has not asked for this, but let me show you how you get it. So it should be the expected of 20 to 100. That is what is required to meet the demand. Because this means that only 10 100 hours will be available for production rather than the expected of 20 to 100. So minus the 10 100. So this gives you the shortfall in the labor hours. So I'll say 20 to 100 less 10 100. So you have a shortfall of 10 100 hours. So this is what we have, the available. We need to use the available to produce. So let's first work out for each of these products the contribution for each. So how do you get contribution? Contribution is the selling price minus the variable cost. So our contribution for the first product, we have the products cotton, we have linen, and we have polyester, shillings per unit, shillings per unit, and shillings per unit. To get contribution, go step here. First step is identifying the limiting factor. Already we know it's the direct labor. So what is the selling price? Because we need to get contribution. Selling price for each of the products. When you look here, we have 1600 is the selling price for cotton, 1340 selling price for linen, and 1300 selling price for polyester. Less the variable costs. Variable costs. One of the variable costs, direct labor. So we have I'll combine the variable cost, the direct labor plus variable production overheads. So instead of going the long way, let me have less the variable cost per unit. So we have variable cost of, for cotton, 480 is the direct labor cost. No, direct material is also variable, 350 for direct materials, plus direct labor is 480, plus the variable production of 150. Variable production overheads of 150. So I should be lessing 980 there, which is a combination of the three variable costs, because fixed cost is not, you should be less it. So the other one for linen, you combine the 365, which is the cost for direct material. Direct labor is 240, so plus 240, plus again 115, which is variable production overhead, and I'm getting 720 here. For the polyester, it is 255 direct material plus direct labor 210, plus another variable cost of variable production of 205, getting 670. So that I can get my contribution margin. So this one, you get your contribution margin. So which will be 1600 less 980, 1600 less 980. So I'm getting a contribution of 620. Then 1340 less 720, 1340 less 720, that is for linen, getting 620. Then 1300 less 670, and I can see you have 630 here. So what is the limiting factor per unit? You also need to get the contribution per limiting factor. So this is the limiting factor. So for this limiting factor, we are told each direct labor hour is charged at 120 for cotton. So how many hours do we need to produce 1 unit of cotton? So this is what we need to understand. So like cotton, we are paying 120 shillings. That is what the direct labor cost is given there. Each direct labor hour is charged 120 shillings per 1 hour. But how much do we pay for cotton as direct labor is 480? So we paid 480 for 1 unit. So how many hours or direct labor hours were they, or do we need to work to get 1 unit of cotton? Because we had paid, when you look at the direct labor for cotton is 480, and 1 hour we pay 120. So how many hours do we or are required to work on 1 unit of cotton? Because we paid 480 for 1 unit, so it should be 480 you divided by 120, because 480 times 1 divided by 120. So this should be 480 times 1 divided by 120, and roughly this is 2 hours. So when we need 2 hours here, cotton, it is the same for linen. You look at what we paid. Linen, 1 hour is also 120 as we have been given. we are told each direct labor hour is charged at 120 shillings for cotton, 120 shillings for linen. So linen 1 hour is 120 shillings. But look at how many hours were they or we worked for. So what is, sorry, this 480 divided by 120, sorry, it is not 2. 480, it should be 4. Divided by 120, this should be 4, sorry. So these are 4 hours. This is 120, and they worked, when you look at the direct labor for linen, is 240. So for 240, this is what will be 240 times 1, divided by 120. This is now the 2 hours. The last product is polyester. Polyester, we are paying 70 shillings. You can see there we're told, and 7 shillings for polyester is 1 hour. So look at how many hours. We paid how much? 210 shillings. So this would be 210 divided by 7, this 3 hours. So 210 times 1 divided by 70, 1 hour. Sorry, 3 hours, sorry. 3 hours. So here, the first one divided by 4 hours. Then divided by 2 hours here. Then 3 hours. So get the contribution per limiting factor. So contribution per limiting factor, I'll write LF. 620 divided by 4. 620 divided by 4, I'm getting 155. 155. 620 divided by 2. 310. Then 630 divided by 3. 630 divided by 3. This is 210. Then you need to rank these products. The one with the highest contribution per limiting factor is ranked number 1. So the number 1 product, which is giving the highest contribution per limiting factor, is this one: 6155, 310, 210. So number 1. Number 2, this 210 and 155, this is the highest, and this will be number 3. So if we're to produce, we have to produce the maximum of units of this linen. We go to polyester, then the remaining hours we use to produce cotton, because based on the contribution per limiting factor, it has the lists. So I want to wrap this part here of this side so that I can do the optimal production mix, how we should produce now. And that is what the question requires. It says if the strike goes ahead as planned, advise the management of Jeffy Limited on the product or the product that should be produced if profits are to be maximized. So let's see what you're going to do, whether we are going to manage to produce all. So the optimal production mix. And we produce as per the ranking. The one ranked number 1 is linen. So we start with linen. Linen, 1 unit of linen is here, requires 2 hours. So 1 unit requires 2 hours. Multiply by the demand of these to know how many hours we are going to take, because the hours are limited. Multiply the 2 hours times the demand of linen. The demand of linen, the budgeted annual demand of linen is 2400. So how many hours? These would be hours. This would be 4800 hours. Remember, we have 10,100 hours. So that product, we can produce at least all of it because already the hours is 4,800, but we have the 10,100. So let's go to product polyester here. We go to polyester. The one ranked number 2. Number 2 is polyester. 1 unit of polyester requires 3 hours. So 3 hours times what is how many hours are remaining so far? Let me see. Hours we have, because the total hours, by the way, we should not exceed 1000. So when you less this 48, so 10,100 less the 4,800, you get the remaining of 5,300. What about the demand for polyester? Polyester demand is 3,000. So if you multiply 3 times 3,000, so the balance you've seen is 53. So I don't even think we are going to meet the demand of 3,000 because 3 times 3,000 is 9,000. But the balance here is 10, 100, you less the 4,800. We have even less than 9,000 hours. So we can't even produce the other product. So we can only manage to produce the 2 products. But this one, we can't produce all of it because we have 5,300 hours remaining. When you add the 53 plus 48, it should be 10,100. So we can't even produce, because this one needs the total. This polyester needs, when you meet the demand of 3,000, should be 3 times 3,000 is even 9,000. It is more than 53, which is available. So you must only, the available is 10,100. You can't exceed this. So because the second product to be produced is polyester, you don't need the whole demand. But you need to know how many units of polyester can you produce with the remaining hours. So you will take 5,300 divided by 1 unit is taking 3 hours. So divided by 3. So 1766. 1766.67. So that is what you can produce. That is the optimal production. Produce 2,400 units and 70 of polylinen and 1766 units of polyester. You cannot say 0.66.67. You round up to the nearest whole number. It will be more than 5,300, and that is only available. So you produce 1766, and you can produce half a unit. So that is what was expected to be done in that question, and to get your 8 marks. Thank you guys for watching, and continue subscribing to my YouTube channel. Continue referring more students, more people to me. I am grateful for what you guys are doing to grow my channel and to also reach more people. I've been receiving even some support from even people from Nigeria, people from US. They've been really supportive to me. Thank you. Let's meet in our next class.